In video number 151, I showed you step by step how you can build the boards I show in my videos based on pre-assembled PCBs from JLCPCB. Today we are going a step further and I show you a video from channel viewer Ben Perreau, who is building a PowerShield from a raw PC board, manually placing and soldering all components. Hello everyone and welcome to the IoTT channel. I am Hans Tanner. Welcome to all new subscribers and welcome back to everyone else. I am happy you made it here and thank you for your support of my channel. It has been a while since the last video and you may wonder what's going on with the channel. A big thank you to all of you who reached out to me asking how things are going and offering some help. I indeed had to shift some priorities over the last few months, and I plan on doing a channel update video in a few weeks to talk more about that. So if you are interested in knowing where things are going with the IoTT channel, make sure to subscribe so you stay in the loop. I remember when surface mount technology became mainstream. That was somewhere in the early 1980s. And I was an engineering student at that time. We discussed the new component size and pretty much agreed that this was going to be the end of hobby electronics, as dealing with such small components by hand almost seemed to be impossible. Now, 40 years later, SMT is standard. As hobbyists, we have learned to use SMT components, and by now I even use them for early prototype boards. And I know of several of my viewers who have successfully built their own boards based on the designs I published on GitHub. Ben Perreau is one of them. He has successfully built several of my boards, and today he is showing how he builds some PowerShields. Note that he is building the external version of it, the one that uses the IBT2 modules available for a few bucks on AliExpress or Amazon. This saves a few components, but the principles of preparing the components and boards, applying solder paste, placing the components and finally soldering and testing the boards remain the same. So here we go.
Hello, my name is Ben Perreau, and through some email conversations with Hans and mentioning to him that I am in the process of fully assembling booster boards by hand, he asked me to create a video to explain the process and help others who might be tempted to go the DIY way but not really familiar with SMD soldering, which is generally the largest concern. This slide is a high-level snapshot of the electronic components of my plan layout, and we will focus over here on the top left portion, which is the silver hat with 6 booster boards inside. Also, I will have a quick video at the end of this whole scheme working on a test layout. So, if you want an IoTT PC board, you basically have 3 options. The first one is to buy from Hans in the store, all finished and ready to go. This is a very good option if you only need 1 or 2 boards, as the cost is very reasonable, as well as the shipping, as the boards are already in the USA. The second option is to buy a pre-assembled board with all the surface mounted components already placed and soldered. This is a good middle ground solution if you need multiple boards and are not willing or comfortable soldering SMDs. Hans has already reviewed how to do this in his video number 151, so we'll skip this option to focus on really the number 3 option, which is going the full DIY. Now this implies ordering the boards from JLCPCB and the components separately from LCAC and assemble everything. This might actually not bring a drastic cost reduction versus the first or second option because of the shipping, which is relatively expensive. But it's a good one if you like tinkering and you want to have a better understanding of the electronics. As a bonus, Hans also managed to get a $60 coupons for your first order with JLCPCB, so don't forget to order it this way. I'm not sponsored by anyone, but I have to say that I'm very satisfied with their quality, their pricing, and how fast they're able to turn the boards around for shipment. Let's dive into option number 3 now. But in order to have a broader understanding of what the Silverhat board is doing, I generally like to summarize all the key information from Hans' video into a single document that you see here. There is a lot of information to capture, and Hans has made 6 videos just on this. Next, you will need to download the files that Hans is sharing on his GitHub page. The link is available in some of his video, and once you're there, you want to click on the IoTT stick folder. This will open another folder with all the data in there, and just click on the green code that you see the window over here and download the zip file. Extract this zip file into a local folder and be sure that you know where the 3 key files are located, namely the Gerber file, no need to extract this one, the bill of material spreadsheet, as well as the pick and place spreadsheet. With this in hand, you're now ready to open your browser and place your purchase of the pre-assembled PC boards. Here as well, the buying process is very similar to what Hans describes in his video number 151. But in this case, since you will be placing all the components by hand, buying the stencil is really a must to ensure the right amount of soldering paste is placed in the right location. Once you order the boards, you now have to order the components. The best and the most inexpensive place that I have found is LCSC, also located in China. If some of the components are out of stock, then either find an equivalent from another supplier on LCSC or order it from Mouser or DigiKey here in the USA. The key column in that Excel bill of material is the LCSC supplier part number that I copy one by one and I transfer onto the LCSC website and then click to search for it. In this case, this is a chip. It is in stock, as we can see here, and we just need to decide how many we need to order based on the previous Excel bill of material spreadsheet. Click on the add-on to cart, and when all said and done, select your shipment method and the cost, pay, and you're done. The components will show up at your doorstep generally about 1 to 2 weeks later, nicely individually packaged, and I keep them as is in various bins. I have one for the resistor 0402 size, I have one for the resistor 0604 size, the chip, the capacitor, diodes, transistor, connectors, etc. Now that you have everything in front of you, I would recommend to also prepare the assembly step by step by creating another overview document showing the PC boards and where each component will be going. There are different methods here. Hans mentioned that he likes to go through by component size, aka place the small one first and then go by the growing size. My approach is to go by categories, aka resistor first, followed by capacitors, the chip, etc. Do not place the extra large components like the through hole connectors, those will be sorted by hand after the SMD placement and soldering is finished. Because SMD placement process takes time, and honestly I'm really easily distracted, having a reference document that you follow to the letter really limits the amount of mistakes that I was doing. Note that because the components are very small, it is very difficult to identify them and know their value, which makes debugging quite difficult, especially if you mistakenly place one in the wrong spot. So take your time, have some classical music in the background and proceed step by step till everything is placed. Because you will end up with plenty of very small components in hand, having them separated in bins is critical. But first you have to transfer them out of their packaging. I made a quick video on how I'm doing this. So this is how you receive the components from LCSC. The key part here is really the reference that gives you everything you need. You got 1,000 pieces of those small SMD here. I only need 20, so what I do is I cut about 24. They're so cheap that it doesn't really matter. And then the problem is how you get those out of the film over here without losing all of them. And for this, my trick is simply a coffee filter, because what you do is you start peeling, and that's sometimes hard, and you need your little tweezer to be able to get there. Once you get it, then you peel it off, and they all fall down. They don't fly all over the place, and they all fall down in that coffee filter, which is then easier, much easier to transfer. Everything is out, to transfer it out into the final box, which in this case, that's my component number 2. So I created those 3D little bucket that are marked with the number at which time I will place the component. I take all those guys and I transfer them into that little block. All there. And plus I have some spare in case they fly out, because that's fairly easy. It's not the smallest one, but it's fairly easy to misprint, and then they jump and bing, that's it, you lost it. Good luck to try to find it.
So before you apply the components on the PC board, you will have to apply the solder paste onto the pads. There are different methods on how to do this, but the easiest and the best one in the beginning is called the tape approach. There's a good YouTube video already on how to do this by Electronoob. So search for it, watch it, and really follow it. I used this approach for a long time and it works very well. But as I like to make things more complicated than they really need to be, and I'm lucky enough to have a 3D printer, I did a vacuum assembly box to hold the stencil in place while applying the paste. I do not think that you need this contraption in the beginning. The tape approach, again, works perfectly fine. So here are 2 pictures of the results where the soldering paste is now on the pad. The left picture is perfect, as you can clearly see the separation between the pads. This was the first board that I did, meaning that the bottom of the stencil was clean and there was no space really for the paste to go between the stencil and the PC board. The right picture, on the other hand, is less than ideal. As you can see, the paste is now smudged between the pads, and this was simply because I did not clean the bottom of the stencil with IPA and paper towel before doing a new board. That means that this introduced a gap where the paste could go, and this is the end result. It's not a major issue though, and I still use it, as you will see on the next video, simply because the paste will melt when soldered and it will self-relocate onto the pads and the components. The key thing here is the volume of the paste, as too much in one area will create potentially a blob when melting, and that might be resulting in a short circuit. Also, some of the tools that you will need are the tweezers, pretty essential. At least a strong light, and preferably more than one, and some magnifying headbands if your eyes, like mine, are not young anymore. For the soldering paste, I like to use a medium temperature that will melt at 180 degrees Celsius. They have a limited shelf life of about 18 months, as the internal flux liquid will eventually dry out and make it harder to squeeze out, as well as spreading on the stencil. So check the date written on the package before using. Lesson learned. Let's now look at a quick video showing how I place the components. So here it goes.
All right, so now we can start with the assembly. And again, in front of me, I have my list of all the components in all the different reference bins that I'm going to be using in a second. And together with the exact location where, for instance, over here, R11 and R12 are located. And I know that in bin number 1, this is a 1 kilo ohm resistor that I have in here. So I'll put that there in front of me. I'll put my bin number 1 right here. I know that this bin's got
all those tiny resistors that I need. I take my circuit board. It's important to have very clean surface so you see what you're doing. I'm going to try to zoom in. So I have my magnifying glasses, and of course I'm banging my head on it. So there is R11. I try to place it in such a way that when I take the SMD with my little tweezer over here, and Hans, thank you again for making those as small as possible, I can go and try to find where R11 is, right there, and I put it on. And that's all there is. R11 is on. The next one is R12. R12 is right there a little bit, right there on the bottom. The trick is to be able to pick that small resistor with your finger. I use both hands generally. One hand, the left hand, stabilize the right hand, and I put the little guy right there. It does not need to be very accurate. It does need to touch on both sides where the paste is, because otherwise it might be turning. And I'm done with my first board with those two resistors, 11 and R12. So what I do is really serial. I put that one aside. I take my next board. I know where R11 is, and here we go again. We start. R11 is right there. Is it on the camera? No, it's not. Right there. And here we go. It's on. Can you see R12? Yep, R12 is right there. I pick it up in the bin. Nope, I don't have it. Now I do. And you put on R12. R12 is in. Next one. And I go like in a serial process like this, one after another. Component number 1, move to component number 2, 3, 4, and so on in series. Go 1, 2, 3, 4, 5 boards, one after another. So the risk of mistake is reduced because you always place them in the same location.
So you are now done with the component placement and ready to move to soldering. But for this you will need a flat source of heat to melt the soldering paste. Hans has a small portable oven to do that in video 151, but I think a better approach to spend a little bit of money to buy this chip hot plate that I have here on the left. It connects directly to the 110 volt and does not have any temperature adjustment, but it does a job. It gets pretty hot as well on the top as well as under, so watch out for what you have under it, so it might deform it. I had a cutting pad and it got badly warped. That silicone pad is really ideal for this, by the way. So I recently bought a more expensive, larger plate with temperature adjustment, but although it works very well, having a large plate to solder a small PC board means that your hands will be hovering over the hot plate, as the PC board should really be in the center when you melt the paste. So to avoid getting burned, I'm using a barbecue glove actually on one hand in order to manipulate the plate and the tweezer if I need to. Again, here's another video going through the soldering.
All right, so we are not ready to solder all the boards. All the boards are populated over here. My plate is heating. I got the setting at 210 degrees, 194, so it's almost there. From a population standpoint, everything is placed, as you can see over here. It sticks to the component sticks to the PC board with the soldering paste. And the next step is pretty simple, as you drop it gently on the hot plate. If I zoom in, we will see that at one point in time I have two of my little tweezers At one point in time, you see the smoke coming, that's normal. The soldering will start melting. I'm at 198 degrees right now, so still a little bit to go. There you go. You start seeing all the different plates, the different pins on the chip. It's melting and you see the resistors moving into place, like that R6 for instance. Up, it's soldered. I have some short circuit on the chip that I did not populate over there, so that's something we're gonna have to clean up. The capacitor will take a little bit more to solder, because more heat, because the pads are bigger. But for the rest over here, as you can see, it's melting over there. This portion is slightly off center. I'm at 205 right now, so you just be patient. And in one point in time, there we go. The soldering is melting and the components are soldered in place. Now you see that R3 over there is lifting up, so sometimes you need to just go and try not to burn yourself. Give it a little bit of an adjustment. It's not easy with a camera, but you try to put it back in place. And that happens generally because the components was not making contact correctly with the PC board. So now we have the capacitor melted as well, and we are good to go with that board. So I gently try to pull it up. I have one of those tweezers with a flat end. Try not to burn myself. I hold it, and I have a silicone mat over here where I drop it so that it can cool.
All right, the next step is then to have a thorough visual check of the board, as not everything goes always to plan. You sometimes have to fix things manually. And the most common issues are components that are not soldered correctly over here, like this picture, or in a case you've seen before, too much paste creating a short circuit. Here is a video on how to fix that. So as you can see on this one, R24 is not placed correctly. I wanted to bring just a little bit of paste in there, but way too much came out. And now I need to go and clean it up and remove the vast majority of that paste out. So I take my tweezer, paper towel, and go and try to remove as much as possible. You don't need a lot of paste really in there, and I think this is okay. So now I'm grabbing my tweezer on the left hand, the soldering iron on the right hand. As you can see, the paste is melting very quickly and is coming into place. And it's just a matter of locating, turning that resistor, holding it in place with the tweezers so it stays in there, and that's done. I think Hans would say go and use your heat gun for that. Each one's got their own approach and method. For just one, I'm using my soldering iron. So to remove the short circuits on the PC board, I'm using a desoldering wick. I apply some liquid flux to help to make this as fast as possible. The wick does not need to be very long because it dissipates the heat. You place the soldering iron on top of the wick and you just simply turn like I just do over there. And the wick just absorbs and clean the pad, absorbs the soldering and clean the pad pretty well. You take some IPA alcohol after that on a Q-tip and you clean the whole surface. So that's it. You're almost there. Just need to solder those through hole components, namely the various connectors, as well as those little jumpers, and you are done. If the components were placed according to plan and there's no short circuits, you should be good to go for the electrical testing. Hope you enjoyed this journey, and as promised, here is a video of the finished product. Thanks for watching.
So this is a test layout that I did to test all the different configuration and be sure that everything was working correctly together. As you can see, I'm a Marklin HO3 rail person, meaning that I'm using the Marklin CS3 Central Station 3. And as you can see on the detail over here, I'm using the MFX protocol to really go and power that locomotive. So it's not DCC, but the Silver Hat works still very well with it. That central station has two outputs. One of it is going to the programming track. The other one is normally going to the layout, but is the MFX signal that is fed to the interface over here. There are under the interface, as I mentioned, auxiliary board. There are 6 layers of booster, and obviously at the bottom an Arduino with the Silver Hat software running it. So I have 6 outputs coming over here, 3 of them powered by this power supply with 18.9 volts, 3 of them powered by this one, 18.7, yep, close enough. I'm only using 2 of them. The other 4 are not used in this test. And then the first one powering the left side, the right one powering the right side of this setup. I got like a little voltmeter, ammeter to check what the current coming out of it, to be sure I'm not going overboard. The rest of the installation, I'm using the IoTT green hat over here connected to an interface board to a LocoNet network that is going to the computer. I'm going to go through that in a second. I designed those interface board that work with the isolation of the Marklin. So when a locomotive is coming onto a sensor, it actually sends on this cable the MFX signal directly into that board. That turns into that little LED as it goes over the sensor, and that feds into the input of that board for the block detection. The outputs are going to the servos. I designed some kind of 3D printed servo that goes under the turnouts. Those 2 guys do not have a servo. They're still using the original Marklin magnetic coil, and because of that I'm using that interface where 3 of the output are coming into that power board. I'm only using 2. The third one over here is used for the decoupler. So the rest of the installation, all that is controlled by computer. I got my LocoNet cable coming here into the computer. I'm using software called RockRail to control all the interface. I can move obviously all the different turnouts, and on top over here I can also have the interface directly to the M5 stick and the different interface that Hans provided for the different hats that are over there. And speaking of hats, I wanna thank definitely Hans for all the work that was involved into creating all this. A lot of time, a lot of work, recognize that. All works well. So Hans, thank you very much for everything you've did here. It is really, really much appreciated effort. Thanks again.
And that's it for today. Thank you, Ben, for sharing your ideas with us. I hope this information was useful or at least interesting for you, and it motivates you to build your own boards from scratch. I became aware of Ben's activities the first time when he sent me some emails with questions about building the boards. And that is, of course, what I encourage you to do when you are stuck in the process. Drop me a message or leave a comment below. I usually read them within a few days, and I am happy to help you to keep going. If you enjoyed this video, please click the like button below to let me know. It takes only a few seconds, but helps a great deal with promoting this video and the IoTT channel in general to other model railroaders, because YouTube likes the likes. Thanks for watching and see you in the next video.